Hi dear students, welcome back to computer science class. In our previous session we have seen number systems, various number systems and conversion from binary to decimal and decimal to binary, right? How to convert binary to decimal? We follow what multiplication by 2 raised to the power of, okay, 2 raised to, okay, yes. And how we have converted what decimal to binary? It's we follow division, okay, division by 2, right? And in the case of fractional part, it's by multiplication by 2, and we consider the integral part out, okay, just for the answer. And at the time of division, we consider value from bottom to top, and at the time of multiplication, we we take value from top to bottom, right? Okay, that's the order. Yes. Here we have our next conversion. It's from decimal to octal, and we have of course octal to decimal as well. Yeah. So how to convert decimal to octal? Decimal to octal. Yes. Here it is. We have a decimal number 759. When we write 759 without any base, it will be a base 10 number, right? It's a decimal number. Okay. So how to convert decimal to octal? We follow division by 8, okay. So just like what, converting the decimal to binary, right? Okay, decimal to octal. Decimal to binary we divide by 2, and decimal to octal it's by 8. That's it, okay, very simple. Yeah, 759 by 8 we are getting 94, and the remainder value is 7, and 94 we are getting 1 1, okay, and the remainder is 6, and 1, okay, remainder is 3, and for 0 we cannot divide 1 by 8, okay, so we are writing 0 in place of this, and 1 as the remainder, okay. After that we consider value from bottom to top. 1 3 6 7, 1 3 6 7 base 8. You have to specify the base because we are converting to this what, octal, okay. We may not have what, base only for decimal value, okay, yes. For all other number systems we must have the base or radix, yes, okay. So this is all for the integral part. Let's look at the fractional part. Here it is 0.125. 0.125 means 0.125 base 10. It's equal to, yeah, how? If it is what, division, for the fractional part it is multiplication. We have seen the case of what, decimal to binary, right? Decimal to integral part we follow division by 2, and fractional part multiplication by 2. The same way here for decimal to octal, for integral part it is division by 8, and fractional part multiplication by 8. That's it, okay, yes. 0.125 into 8 we are getting 1.000. When we are getting 0.000, no need to proceed further, okay, because we are getting 0 again. Yeah. So if the doesn't come 0 in your first multiplication, what to do? You have to proceed the steps up to at least for 5 values, okay, at least for 5 values. Yeah. So here the answer is 0.1 base 8. Please do not write 1 base 8, okay, because we are converting decimal fraction. So the result must be a what, octal fraction, okay, must be an octal fraction. Yeah. So it is 0.1 base 8. One more thing, don't write 0.1 base 8, okay. You must have 0. You must have 0 just before what, point, okay, decimal point, yeah, or octal point, yeah. 0.1 base 8, okay. So this is how we convert decimal to octal. It's a very simple conversion. Now we can move on to octal to decimal. Octal to decimal conversion. It's what, 8 raised to the power of, both for the integral part as well as the fractional part, okay. And you can do it for what, mixed number, right? Like 759.125. Yes, you have to do it separate. Don't do it, okay, together. Do it separate. First you do it for the integral part 759. After that you consider 0.125, okay, because the operation is not same for integral part and fractional part. For integral part it is division by 8. For fractional part it is multiplication by 8, okay. So next is octal to decimal. We have an octal number 47. Please do not pronounce it as 47, okay. 47 means it's a decimal number. It is 47, okay. Yeah, 47, and we are rewriting it 47 just for writing the positional value, okay. Yeah, for 7 it is 8 raised to 0, we know that, and for 4 it is 8 raised to 1. Then how? 4 into 8 raised to 1 plus 7 into 8 raised to 0. Just like 1 into 2 raised to 1 plus, okay, 0 into 2 raised to 0, whatever it is, okay. Then it's 32 plus 7, 39. Okay, either you can write 39 or 39 base 10. Okay, both are right, yeah. So this is how we can convert integral part of octal to decimal. Then fractional part. 0.34. We are rewriting it 34. And we know just after the decimal point, it's like what? Minus 1, minus 2. It proceeds like minus 1, minus 2, minus 3. Okay? Yeah. So here for 3, the position value is 8 raised to minus 1. For 4, it is 8 raised to minus 2. Okay? Yes. Then 3 into 8 raised to minus 1 plus 4 into 8 raised to minus 2. You have to perform what? You have to know what 8 raised to minus 1 is. Okay? 8 raised to minus 2 is. For bigger numbers, for your exam, the value will be given. Okay? Yes. Don't bother about that. Yeah. Then just multiply and add. We get 0.4375. Okay? 0.4375 base 10. So this is how we can convert octal to decimal. Octal to decimal is very simple. We multiply the place value with the face value. That's it. Okay. 8 raised to for the integral part, 8 raised to with 2 right to left, 8 raised to 0, 1, 2, 3. Okay. And to right, minus 1, minus 2 towards right again. 8 raised to minus 1, minus 2, minus 2. Okay. All that. So this is how we can convert decimal to octal and octal to decimal. Decimal to octal, we follow division and multiplication. But for octal to decimal, we follow multiplication. Okay. So this is how we can convert these two, octal to decimal and decimal to octal. We just practice with more examples. Okay. There are more examples available in your textbook. Okay. Just go through it or find it yourself. No, it's not a must. Okay. Just go to your textbook and find some problem. Just create your problems. Okay. That's the best method. Okay. Just write a random number and do it. Work on it. Okay. That will be a very good approach to have a skill on this. Okay. Yes. So this is all for the time being. We can have more conversions in our coming classes. Okay. So thank you for watching. Have a nice time.